All right, if you're building with LLMs, you know the single biggest threat to getting anything reliable into production is hallucination. So today, we're going to break down a really powerful engineering pattern designed to fight it: chain of verification. Let's get right into the nuts and bolts of how this thing works.
So let's just kick things off with a statement that, well, it pretty much challenges one of the most popular prompting techniques out there. For years, right, we've all been relying on chain of thought to improve reasoning, but the research is crystal clear. When it comes down to just pure factuality, thinking step by step is not the same thing as checking facts. And that single insight, that's the entire reason chain of verification even exists.
And look, let's be clear. Chain of thought is awesome for breaking down complex reasoning problems, but it has this critical, fundamental vulnerability. It just doesn't have a built-in way to check if its own foundational facts are actually true. And this creates a really strange paradox, where a model can sound more and more logical while becoming demonstrably, provably, more wrong.
The real heart of the problem is a core behavior of these autoregressive models, something called one-pass generation. Basically, the LLM generates token by token, one after the other in a straight line. It writes a confident-sounding answer and just keeps on going. It can't just pause, reflect, and ask itself, hey, wait a minute, was that first thing I said actually correct? So if it makes up one tiny, plausible-sounding error right at the beginning, every single token that comes after it will treat that error as ground truth.
And this, right here, is where things get really dangerous for production systems. That one-pass generation creates this vicious feedback loop. The model spits out a flawed fact. It has no way to self-correct, so it then builds this beautiful, logical argument right on top of that broken foundation. It literally starts reinforcing and elaborating on its own mistake, making the hallucination more detailed, more convincing, and frankly, a lot harder for you to spot.
So how in the world do you break that loop? This is where the chain of verification protocol comes in. And you got to understand, this isn't just another prompt trick. It's a structured, multi-stage process. It's designed specifically to force the model to stop, to interrogate its own claims, and then to revise its work based on actual evidence. It's a direct counterattack on that one-pass generation problem.
And the process itself is disciplined and, brilliantly simple. First, you just let the model generate its normal initial response, call it the baseline draft. Step 2, you prompt it to look at its own draft and come up with a list of verification questions to fact-check every single claim it just made. 3, you have the model answer those questions. And then finally, you tell it to generate a final, revised response using only the answers from its verification step as the source of truth. But the devil, as we're about to see, is really in the details of that third step.
Now that 4-step process on its own is pretty solid. But the research found one specific detail that makes the entire system dramatically more effective. Honestly, if you take one thing away from this whole explainer, this is it. This is the most important technical bit.
So what is it? What's the one thing you absolutely have to get right to make this whole thing work?
One word: independence. That is the key. And understanding why it's the key, well, that's what separates a decent implementation from a truly great one.
Okay, this distinction is everything. You can run CoVe in 2 ways. There's joint verification, where the model can see its own draft while it's answering the verification questions. But then there's factored verification, where you actually hide the draft during that step. And this is the absolutely crucial point. If the model can see its original draft, it is incredibly likely to just copy its own hallucination all over again. By hiding the draft, you force an independent lookup. You completely break that hallucination feedback loop we were talking about. So this all sounds great in theory, but as engineers, we need to see the numbers, right? So let's get to the data and see how this actually performs in practice.
Okay, so the first big area of improvement is on tasks like generating a list of things. List all the movies directed by some person. These tasks are notorious for sneaking in subtle, made-up items that look totally correct.
And the impact here is just stark. With a standard few-shot prompt, the model was pumping out, on average, almost 3 hallucinated items per list. With chain of verification, that number absolutely plummets to just 0.68. I mean, that is a massive, massive drop in the error rates.
And it's not just about making fewer mistakes, it's about increasing the density of correct facts. On a Wikidata list generation task, CoVe more than doubled the precision. The output isn't just less wrong, it is fundamentally more trustworthy. The second key area is what's called closed-book question answering. This is where you ask the model a question, and it has to rely only on its own internal knowledge, right? No peeking at external documents.
This is an incredibly hard task where factuality is everything.
So, on the really tough multi-span QA benchmark, CoVe delivered a 23% relative improvement in the F1 score. It jumped from 0.39 up to 0.48. And for those of you who track these benchmarks, you know that a jump that big on a mature task is a really significant achievement. It shows that CoVe isn't just cleaning up the easy stuff, it's improving performance on tough, nuanced problems.
So what does this all mean for the systems you're actually building? Well, it means fewer incorrect items in those generated lists. It means biographies and summaries with fewer bogus dates and wrong affiliations. It means you get more reliable answers from your internal knowledge bases. And maybe most importantly, it means the model is way less likely to be overconfident about facts it's not sure about, because that verification step forces it to confront its own uncertainty.
Okay, so let's boil this all down. What's the big engineering takeaway here? What do we need to walk away with?
I think the most important takeaway is this. Chain of verification is not some magic prompt. It is a deliberate engineering pattern. You are fundamentally changing the generation process from a single uncontrolled fire hose of text into a structured pipeline. You're building a system where the model is forced to draft, then interrogate itself, then execute checks, and then revise. It's really about imposing discipline on the model's own process.
And that really leads us to the final question you should be asking about your own systems. You've probably spent months getting your LLM to think, but have you engineered a process to make sure it's also verifying?